आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Dr. Rajeeb Lochan Mishra digs into ancient earthquake scars hidden in the Himalayan rocks. His work helps predict where the next big one might strike, helping engineers build safer schools, hospitals, and homes for millions. Listen in.
I am Dr. Rajeeb Lochan Mishra. I work as a scientist B in Wadia Institute of Himalayan Geology, Dehradun. Basically about me, I belong to Odisha from the Cuttack district, and I am working here as a scientist B in the post of scientist B since 10th of May 2022. And my research area in brief is paleoseismology and active tectonics, and also geodynamics basically. So this is I have been working in this field, sir, for the last say 12 years or so, and I have also I'm also trying to expand my field to some numerical modeling sort of thing. You must be familiar with the occurrence of earthquakes because the earth crust, as we know, is divided into a number of tectonic plates basically. So these plates, when they interact with each other, when they during interaction, so we have the occurrence of earthquakes basically. So the Himalaya is has been formed in one such plate boundary, that is a continental plate boundary, where the collision between two plates, tectonic plates, that is the Eurasian plate or the Tibetan plate and the Indian plate, are continuously colliding since the Cenozoic. So now what happens? These earthquakes leave some kind of some geomorphic imprints, geomorphic signatures sort of thing, as we call them in simpler language. So we identify them using satellite data basically, and later on cross verify these structures. You can say these are baby mountains basically. So as the Himalaya is attaining its growth, its topography, so these we call as fault scarps. So these fault scarps are basically just like a baby mountain, as if they are growing like the Himalaya. So we identify them and we cross verify it on the field, and we excavate trenches on them basically. So by excavating trenches, we dig out the material from it, and we expose the walls on both sides. So we date these walls with the help of suitable dating material like radiocarbon, charcoal. If we use charcoal, we are aiming for radiocarbon dating, AMS dating, and we also use other quaternary dating methods like luminescence dating, TL-OSL dating, that is optically stimulated luminescence dating. When we are not getting charcoal, we use that. So we assign ages basically to the different stratigraphic or soil units that we observe in the trench. So in this we say that, and we assign a particular age to the occurrence of earthquake. That means the timing of the occurrence, timing during which or the year during which an earthquake has occurred in the particular place, and which led to the formation of a fault scarp.
Okay.
So Basically, our work is directly related to the directly having societal significance, sir. Because we are providing the by our study provides the timing of the event, the size of the event, that is we call magnitude of the event. So what is the what magnitude of earthquake occurred at that place, and the recurrence also, we the recurrence interval of the earthquakes. That means after how many years such a great event meaning we call those events are called great events which has magnitude 8 greater than 8.0 basically. So only those events that are greater than 8.0 magnitude are able or are capable to produce fault scarps or to produce surface impressions in the form of fault scarps. So we identify them and we talk about the recurrence period of these such great events in the Himalaya. So it is directly having a societal implication. Research area which on which I am planning to work in the future, sir. Basically, I want to integrate the numerical simulation into the field of paleoseismology. So with this, what will happen? We will have a brief. We will have a clearer insight into the into how these active faults on which we are excavating trenches behave during large earthquakes or will behave would behave in future earthquakes. Suppose we expect a future a big event or a great earthquake in the future or in the present day. So basically in the active fault zones we are having many large engineering infrastructures like dams, bridges and reservoirs and all. So we still not have any kind of parameter to analyze or to have a clear idea of what impact will us with such a great event having a magnitude more than 8 greater than 8 will have what impact will such a great event have on these large engineering infrastructures. So with the help of numerical simulation, so it would be possible. So I am planning for that, sir, to integrate it with paleoseismological studies. And because in paleoseismological studies we are already providing the fault parameters, geometry of fault, the fault dip angle and other things. So which is being directly useful in deterministic seismic hazard models. And apart from this, I am also I have a plan to, I have an aim to generate an inventory of active faults for the entire Himalaya, and that would be a breakthrough contribution from my side, being a researcher in this domain basically. If we talk about the research domain, that is paleoseismology and active paleoseismology to be very specific. So we have competitors like US and also some French people are also mainly working in this area, and with their comparison, India is also, we are basically contributing enormously in this field basically. So but in the Himalaya, to be very specific, because this is where I have been working, and mainly the paleoseismological studies in this country are being subjected to, so being done or being undertaken. So in the Himalaya we have apart from us, we are having also some foreign research groups who are working in from US and France also. They are working in collaborations, or Nepal is also conducting, but we are also contributing exceptionally well, sir. And to be very honest, we have only 3 research groups in India who are working dedicated to the field of dedicatedly in the field of paleoseismology, and our group from Wadia Institute is a leading group in this field basically.
Okay, but any industries collaboration you're looking or
No, I think we don't have this. This field does not have the scope for industrial collaboration, sir, because what we are doing, it's purely science. So there is no industrial component involved. So since PhD, I have been publishing in good journals. Basically, so as of now, I have published in almost 12 research papers in different journals. So two of my papers are in geophysical research letters. So with an impact factor, sir, I think 4.8. Excuse me. And tectonophysics, there one paper was published in tectonophysics in 2024 last year. So it has an impact factor 2.7. Then two papers in scientific reports, that are Nature Portfolio Journal, and with an impact factor 3.8. One in geoheritage, impact factor 2.3, and then a paper in current science, 1.1 impact factor, and another in structural geology, that is having an impact factor of 2.6. Apart from these, I have also published two papers in Arabian Journal of Geosciences and another one in Journal of Earth System Sciences, that is Indian journal basically.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.